everyone. Today we're going to be doing more trig integration. So starting off with integration of tan cubed x dx, integration of sec cubed x dx, and any of that general form. And then we're going to do a little bit of trig substitution. So hopefully we can get this done in a quick video because I got a class coming up right away. So let's go. So last video we did a few ones, and this is just to top it off. We didn't get to this yet. So we're going to integrate tan cubed x. All right, so how are we going to do this? What we should do is we're going to split tan squared x and then tan x out. All right, so this is going to bring to mind we need something that differentiates into tan x dx so that we can use substitution, right? Well, if you remember, 1 plus tan squared x is equal to sec squared x. All right, so we do this. 1 and if you remember, sec squared x sec x differentiates into tan x sec x. So we're going to get to that in a second. So we're going to have let's have tan squared x. We substitute this here. Let me just do that really quick. So that's sec squared x minus 1. Then we put here sec squared x minus 1 tan x dx. Okay, so now if we want to let u equal sec x, u equals sec x, and so du equals sec x differentiates into tan x sec x. So now we need tan x sec x in this area so that we can substitute du into it, right? So what we could do is we could rewrite the whole expression as this. We multiply by 1, right? Any number divided by itself is 1. So sec x over sec x is just 1. We're not changing this equation. But look what we have here. Sec x tan x dx, that's going to give us du, right? Here. So we can substitute that into there. So what we're going to say now is sec squared x minus 1, all multiplied, all divided. Technically, I'll rewrite like this. Sec x du, right here. And you can see that up there. And all we have to do now is, if we remember u equals sec x, all we have to do now is we say, we put u in, so this would be u squared minus 1, and that's over u. Du, all of this, so now that would just be u squared over u minus 1 over u du, which is equal to the integration of u minus 1 over u. And that is equal to 1/2 u squared minus ln u plus c. And all we have to do is substitute u into it. Remember, u equals sec x, so it's 1/2 sec squared x minus ln of sec x plus c. There we go. Okay, now how are we going to do the integration of sec cubed x? This one's a little bit more complicated. You cannot, sec cubed x, you cannot, if you remember, right, sec cubed x, and if we want to turn into tan x differentiates into sec squared. So if we have sec cubed x, we need at least sec to the 4 so that we can split it to tan squared, sec squared into tan squared, and then the other sec squared as the differentiation of tan. So what we have to do here is we have to do sec squared x and sec x. And instead of turning it into tan, we have to, I'm just going to check with my notes really quick. So yeah, we have to keep it like this. And the reason why we're doing it like this is because if you think about it, if we're doing it integration by parts, I'm going to put by parts here, right? And so we select something to be integrated. We know that d over dx of tan, basically differentiation of tan x, is equal to sec squared x. That means that integration of sec squared x is equal to tan x. So what we want to do is we can say that u dash is equal to sec squared x. Then our integration of that would be tan x. And here, if v is equal to sec x, then the differentiation of that is tan x sec x. Okay, now we just put this into the normal equation for 5 parts. So uv tan x sec x minus the integration of v dash u. So that's tan x and tan x sec x. V dash u, is that correct? Yes, it is. Okay. So here, we're going to have to do by parts again. So we have, so here we have tan squared, right? Let's rewrite this. Tan squared x sec x. And if we want it to be, we can use the transformation tan squared x, 1 plus tan squared x equals sec x. Therefore, tan squared x equals sec x sec squared x, sorry, sec squared x minus 1. Therefore, this is also equal to the integration of sec squared x minus 1 multiplied by sec x. And the way this is going to work is we're going to add everything together. So sec squared x multiplied by another sec x would be sec cube x minus sec x, all dx, all multiplied by dx. Okay, so we can split this into sec cubed x dx minus integration of, this is a big brackets, minus integration of sec x dx, right? And now let's rewrite the whole equation. I'm going to show you the magic, okay? So we have the integration of sec cubed x, to rewrite the expression that we found, tan x sec x, tan x sec x minus all of this. So I'm going to add that in. So we have minus integration of sec cubed x dx, and then minus, which is plus, integration of sec x. All right, so see how there's 2 sec x dx on both sides. So we can move this over to this side. We can say that 2 integration of sec cubed x is equal to tan x sec x minus this one moved over. So then we have the remaining, which is integration of sec x. And here, therefore, to find the integration of sec cubed x, we just have to sec cubed x dx, sorry. We just have to divide everything by 2. So tan x sec x minus, what is the integration of sec x? It is the ln of tan x plus sec x. And then we have to plus c, and then everything divided by 0. There we go. So that's how we do the integration of sec cubed x. It's a little bit different from how we did it before, and that's kind of tough thing is about that, is spotting that we have to do by parts. So yeah. All right, now let's move on to trig substitutions. Trig substitutions, basically we're going to, it's going to be the easiest to kind of see it through an example. And I have the equations screenshotted to the right so that we can see kind of how to use it. Okay, so I'm going to do the first example. Let's do the integration of 1 over 4 plus x cubed. X squared. 4 plus x squared. So let's look on the right side. What looks similar? Even though there's no square root, we know that 4, if we think about it, it's just 2 squared plus x squared, right? 2 squared plus x squared. So a squared plus x squared right here. We want to use the substitution for x equals a tan t. Okay, so let's say this. Let x equals to a tan t. What number squared is going to be equal to 4? We're going to use 2, and you're going to see why we use 2. 2 tan t. Let x equals 2 tan t. And then, therefore, dx over dt is equal to 2 tan t. Integration of tan is 2 sec squared x, so that's 2 sec squared t. And then, therefore, dx, and this has a dx here. Sorry, I forgot about that. Dx is equal to 2 sec squared t dt. So if dx is on both of this side here, we can substitute this into dx. So what is that going to turn into? That's going to be 1 over 4. Substitute x in first. So that's 4 plus 2. I'm going to square it straight away. So 4 x squared, 2 tan t squared is going to be 4 tan squared t. And then dx is substituted by this. So now that's going to be the whole thing multiplied by 2 sec squared t dt. Okay, so let's do a little bit of factorization. This is how the formula works. So now we have 2 sec squared t over, let's take 4 out. 4, therefore it's going to turn into 1 plus tan squared t, all dt. And if you remember what 1 plus tan squared t is, it's sec squared t. So what we end up with is differentiation of 2 over 4 sec squared t. 1 plus tan squared t is equal to sec squared t. So now we have sec squared t dt. These things cancel out. We have 2 over 4. So what we have left is the integration of 1/2 dt. And that's going to be the integration, that's going to be equal to 1/2 t plus c. And all we have to do now is substitute t back into it. So if we have if x is equal to 2 tan t, then how are we going to find t? What is t equals to? So x over 2 equals tan of t, and therefore t is equal to the inverse tan of x over 2, and therefore we can put that into the equation. The final answer for this integration is going to be 1/2 inverse tan of x over 2 plus c. There we go. The next thing we're going to do, next example we're going to do is the integration of 1 over the square root of 4 minus x squared. Okay, integration of 1 over the square root of 4 minus x squared dx. Okay, so now looking at the equations here, we have 4 minus x squared. So a squared minus x squared right here, this one. We're going to use a sec t dx. Okay, so the way that's going to work is, we'll get there. So, actually, no. This is not, sorry, this is not wrong. We're not going to use a sec t dx because that's x squared minus a squared. In this case, this is a squared minus x squared. And so we're going to use the top one here, a squared minus x squared, and that's a sine t. So we're going to let x equals a sine t. Therefore, dx is equal to differentiation of the sine to cos t dt. Okay, now let's do our substitutions. So into here, we have 1 over the square root of 4 minus what's x, so that's a, sorry, not a, I'm going to use 2, just like the other one. And now it's going to be 4, because 2 squared is 4, and then it's going to be cos squared t. All that here multiplied, dx gets substituted by 2 cos t, so now we have 2 cos t dt. Now, what we're going to do is we're going to put 2 cos t here over, taking 4 out. So that's going to be the integration of 4, sorry, the square root of 4, 1 minus cos squared t. I made a mistake here. I made a mistake, guys. Sorry if you noticed that. This is going to be 1 over the square root of 4 minus, I forgot, I put cos into x. It's supposed to be sine. It's 2 sine, so that's 4. Sorry, guys, long day. Sine squared t, like that, and it's multiplied by 2 cos t dt. And now this is going to be the different integration of 1 over, let's put 2 cos t over here. We have the square root of 4, take that all out, 1 minus sine squared t. dt, and now we can take the 4 out. So the 4 would turn into a 2 out here, right? And so that would cancel out with the 2 here. So now we only have cos t and 1 minus sine squared x, sine squared t. If you remember, cos squared t plus sine squared t equals 1. So 1 minus sine squared t is equal to cos squared t. So that would be the square root of cos squared t dt. Okay, and if you remember, the square root should be a positive and minus, right? It could be a positive or minus cos, technically. So if we were to do this, this could be plus minus cos t, just from the way square root works, right? So what we do is that in the equations, we say that t only exists from pi minus pi over 2 to pi over 2, in which range the cos graph is positive. Therefore, we can assume that's actually a positive cos here, and we can say where t exists from minus pi over 2 to pi over 2. And now this is simply going to be, these cancel out. This is differentiation of 1 dt, which is equal to t plus c. And all we have to do is substitute x into here. So if x is equal to 2 sine t, then x over 2 equals sine t, and t is equal to inverse sine of x over 2. There we go. And yeah, and we just got to remember that t is in this range. So I'm just trying to think, how can we state the range of the x. So I figured it out. So if we have t sine t, and we remember the graph for sine t, right? It goes like this, right? And the maximum here is 1, and the minimum here is -1, and this at minus pi over 2, and this is pi over 2. If we remember, right, on here, the range is there. And so x, oops. And so x, the product of this, so if it's maximum from here to here, which is just the maximum range of sine, that means that x over 2 cannot be smaller than -1, because that would be impossible, because the graph can't go -1 and it can't be larger than 1. And therefore x cannot be smaller. We times 2 to everything, so x cannot be smaller than -2 and cannot be bigger than 2. That should be the final statement of our answer. Okay, final thing, we're going to do the integration of x over the square root of x squared minus 2x plus 5. So the integration of x over the square root of x squared minus 2x plus 5. I'm just going to go check if that's correct or not. Yes. This dx. Okay, so in this case, this denominator is proving difficult, right? How are we going to do this? Well, my first thought was to kind of figure out how we can factorize this. But if you see, there's no factors. If we do the quadratic formula, so minus b plus minus square root of b squared minus 4ac all over 2a, what you're going to find is this in the, I forgot the name. Whatever this is, this section here that shows how much roots there are, if we do that, the square root of b squared is 4 minus 4 multiplied by 1 multiplied by 5. That would result in a square root of 4 minus 20, which is the square of a negative number, right? A negative number. And so this is impossible. There's no roots to this equation. So how are we going to transform it into a way where we can use these trig substitutions? Well, what we could do is we could rewrite this in another form. And a good way to think about it is let's complete the square. So how do we complete the square? Well, we just take x, we remove the x squared, we just keep x, we half the b, so minus 2 half is minus 1 all squared, we minus the root of this, we minus the square of this, so 1 squared is, minus 1 squared is 1, so we minus 1, then we plus 5. This leaves us with x minus 1 squared plus 4. So therefore we can rewrite this equation as x over the square root of x minus 1 squared plus 4 dx. And so in this case, we have a scene where a scenario where it's x something squared plus a squared. X squared plus a squared we would use x equals a tan t. So now let's let x equal because it's for, let's let x equal sorry, let's let x equals 1 minus x minus 1, sorry, equals to 2 tan t. And therefore x is equal to 2 tan t minus 1. Dx is equal to tan, as tan goes into sec squared x, so that would be 2 sec squared x, or sec squared t minus 2 sec, differentiation reduces to constant, so now we have this. So now what we could do is now x minus 1 is equal to 2 tan t, and we have x is this, so we have 2 tan t minus 1 multiplied by, let's do that later. That's that we substituted this into x, and now we need to do x minus 1 equals 2 tan t. We're going to put it into there, so that's the square root of 2 tan t squared plus 4, and then dx is substituted by the everything. So now we put, instead, in place of dx, we put 2 sec squared t dt. So now let's work on this. So 2 tan t is 2 tan t all squared is 4 tan squared t, and then I'm going to do a quick kind of removal of that. So let's work on this. 2 tan t minus 1 all multiplied by 2 sec squared t over, and let's move this out. So now there's 4 tan squared t plus 1 square root of that dt. And so this 2 comes out here. Yes, this 2 comes out here. Yeah, that 2 comes out here. So that becomes a 2 out there. And then we can take the 2 of this one out to here, and these ones can cancel. So what happens now is we get a reduced form into this. And if you remember, tan squared plus 1 is just sec squared x. And so now we have the square root of that. If we look here, sec squared x, I'm guessing this is going to put it as positive. This is how the ranges work. So we're giving it a domain where it's positive, so we can assume it's positive. So now we have 2 tan 2 tan t minus 1 multiplied by sec squared t all over sec squared x. Sorry, this is supposed to be t. Sec squared t gets square rooted into just sec t. And now this one cancels out with this one. So now we just have the integration of 2 tan t minus 1 multiplied by sec t dt. That comes out as integration of 2 tan t sec t minus sec t dt. And this is a simple different integration. So what differentiates into tan t sec t? Well, that would be sec x, right? Sec x differentiation. Sec x is just tan x sec x. And so here we can do this as the integration of 2 tan t sec t dx dt minus the integration of sec t dt. So that will be 2 sec t minus, and this would be the ln of sec t plus tan t plus c. And all you have to do now is just do the conversion from x into t. I'm not going to do it. It's going to take a lot of time, but that's how you do it. Okay, so thank you guys for watching my video on how to substitute trigonometric equations that we're integrating, and on how to integrate sec cube x and tan cube x. I'm going to make another video on partial fractions tonight. Hopefully I can get that done. Thank you guys so much.